Good morning. I'd like to welcome everybody to today's program, World IPv6 Day. What should you do? We're glad that you have been able to join us. A few housekeeping notes to begin. As you entered the WebEx console, you either joined us by audio broadcast or by phone, which was automatically muted. Because of our large audience in attendance today, you will remain muted throughout the event. When you have a question, please feel free to enter that into the WebEx Q&A panel as you think of them. You can find the Q&A panel on the right-hand side of the console. Please leave the WebEx chat window for communication to our WebEx facilitators for any problems or issues you may be experiencing. Again, please enter your questions for our speakers in the Q&A panel. This session is being recorded, and you will receive an email containing a link to the recorded session afterwards. We would appreciate your input regarding today's WebEx through a short survey that will pop up as you close out your browser at the end of the event. At this time, I'd now like to pass it over to our host, Dan Gerson.
For community.
Over to you, Dan.
Thank you, Stefan. Hello, everyone, and welcome to the Cisco Support Community. Today, we present another live CSC Expert Series webinar inside Cisco Live and Networkers Virtual. During our event today, our topic will be World IPv6 Day. What should you do? My name is Daniel Gerson, and I am the Content Manager for Cisco Live and Networkers Virtual here at Cisco. Our expert joining me today is Phil Remaker, a distinguished engineer at Cisco. Welcome, Phil.
Thank you.
Now I'd like to briefly outline the format for today's Expert Series event. Phil will start with a short presentation on IPv6 for the first 35 minutes of the program, and then we will dive into the live question submission for the remainder of the event. During our live presentation, you may submit a question to be answered by Phil and a team of Cisco technical experts using the chat box on the right side of the console. You can scroll up to see previous answers in the Q&A box. The team of technical experts is well-versed in IPv6, so please begin posting your questions now to give us the best chance of answering them. If you experience any technical issues, please post your questions into the chat. We will be asking polling questions today, and we do encourage you to participate by answering them. You may also download a copy of today's PDF in the chat window on the right side. Now, let's kick things off with a polling question. What is your level of experience with IPv6? Is it A, IPv what? B, I'm thinking about using it. C, I'm playing with it in the lab. D, I'm running it in production. E, I invented it. Any questions? Please take a moment to answer. You'll see the polling box on the right side. Don't forget, you can submit your questions at any time. And at this point, I'm going to turn it over to Phil to begin his presentation.
Thank you very much. Oops, I am now the presenter. Great. So I want to talk about why we have a World IPv6 Day in the first place, who is participating in the World IPv6 Day, understanding how it's going to affect you and your network, and the steps you might need to take to prepare, and most importantly, where you can go to get help. So let me start off by talking about, this is a not very precise snapshot of the world according to IPv6. The original plan when IPv6 came out around 1996 or 1997 was that as the size of the internet grew, that we would expect that the IPv4 pool would be used less and less, and that the IPv6 users would gradually pick up using dualstack. Eventually IPv4 would fall into disuse, everybody would move to IPv6, and everybody would be happy. In fact, what we discovered was that the internet continued to grow and almost nobody adopted IPv6 for a variety of reasons. The IPv4 pool eventually drew down to depletion, which just happened February of this year. We've seen it coming, predicted it within just about plus or minus a year from 10 years ago. And now all of a sudden IPv6 deployment is a whole lot more important because we're just out of IPv4 addresses in the internet. Did the poll finish? I'd like to see the results of the poll. I'd especially like to know if the person who invented IPv6 is here. Let's see. Oh, got 10 seconds left. So I'll wait the 10 seconds for the results. So what went wrong? Well, IPv4 benefited from a lot of life-extending technologies. Network address translation was the main one, allowing many different users to share a single address. Classless interdomain routing allowed the networks, which were originally in fairly unflexible blocks of Class A, Class B, and Class C networks, into much more flexible ordinary blocks. Private network addressing, where you could use IPv4 addresses from a private pool. Name-based virtual hosting, where many different websites could share a single IP address. And just general conservation exercised by the fact that people were more clever and less wasteful about their subnetting. Part of the problem is IPv6 originally suffered from an uneven quality of service. We had buggy gateways, bulky stacks, problems with DNS, lots of low expertise, and a pretty tall learning curve. Website operators feared a loss of customers due to IPv6 bugs. This was a common thing where the incentive to go to IPv6, if you went to IPv6, if you were Google and you turned on IPv6, if people had a problem, they would then go to your competitors, Yahoo or whomever. So no website operators really had a lot of incentive to turn on IPv6. Network operators, in turn, there's a chicken and egg problem. Well, nobody's running IPv6. Why do I need to offer IPv6 to my customers? Similarly, OS vendors took a long time. Even though the IPv6 standard was in pretty good shape in 96 or 97, you didn't really start seeing OS vendors until very recently rolling out IPv6. IPv6 appears in Windows Vista and Windows 7. It appears in Mac OS 10.2. Mac OS was a pretty early adopter. You will find it in most modern flavors of Linux. And also iPhone version 4 of iOS and iPhone and Android 2.1 have also picked up IPv6. So although it took a long time to provide IPv6 stacks, almost every modern operating system has one. And applications in turn, because the operating systems didn't have it, have been slow to incorporate IPv6 into their designs. So there were a lot of stalls leading up to this day, but now we've got a pretty good infrastructure of OS vendors and applications that can support IPv6, but there's still a problem of who needs to go before who needs to go first. Before who needs to go first, we take a look at the funny thing happened. Again, on February 3rd, we ran out of IPv4 addresses in the Internet. As of April 15th, the Asia Pacific Network Information Center has run out, and there are 4 remaining regional centers. And these are the projections of this is a probability density of approximately when we expect to run out of IPv4 addresses at each of the regional registries. The next one in line to run out of addresses is RIPE NCC, which is in Europe. The Americas will run out again sometime in between mid-2012 and early 2013. And then Latin America and Africa run out in 2014, 2016, respectively, based on projections and current IPv4 consumption rates. So the urgency of switching to there's a whole new urgency in switching to IPv6 simply because IPv4 has exhausted its address space. So solving the problem of who goes first is what World IPv6 Day is all about. On Wednesday, June 8th, 2011, from Greenwich Mean midnight to midnight, a large number of websites, Google and Facebook originally got together and made an agreement to do this for 24 hours and then put together this concept of World IPv6 Day and got a bunch of people to sign up. So Google, of course, owns YouTube. Yahoo, Facebook signed up. Cisco is on board. VeriSign, Bing, lots of other customers. AT&T's Research Network, YellowPages.com. Almost every major network vendor has gotten on board. A lot of the major content providers. The entire list is at the Internet Society website, which will give you a list of all the participants. But the idea is that rather than me turning on IPv6 and running the risk of my customers bailing, we all put our hands together and we agree on this date we're all going to go to IPv6. So if people have a problem, they can't just change the channel and move to another website. They're going to have to deal with their IPv6 problem, and we're going to get some good data about what's going on. So what could go wrong? The good news is that most sites or hosts will not notice this change. If you're running an IPv4 only network, this should not affect you at all. The typical impacts you'll see for IPv6 networks are things like slow connection startup and slow performance due to congested IPv6 paths. There may be failed connectivity if you've got misconfigured devices or a broken IPv6 path. You may have failed connectivity due to non-compliant devices. There's a whole list of detailed issues. And again, if you pick up the PDF at the end of this presentation, you can go to this getipv6.info. It's a wiki run by Aaron, which is the number assigning board for the internet, and they have a pretty comprehensive collection of all the possible problems that can occur based on the research that's been going on. Cisco.com itself is also participating. www.cisco.com during that 24-hour period will be reachable by IPv6. The experience should be about the same as going to www.ipv6.cisco.com today. A number of sites have V6 test sites set up today. Even if you can go to www.ipv6.apple.com to see their V6 setup. And again, the experience for V4 and V6 will be exactly the same, just the underlying protocol is the same. So, with all this happening, who's going to be impacted? Consider the possibility if you are a website owner or a network operator or an end user. So, under the situation where you are a website owner and you're only running IPv4, you will have no impact, because even if the network operator or end user is running IPv6, if you only run IPv4, they will always connect to you by IPv4, so there won't be a problem. Similarly, if you are an end user that's only running IPv4, even if a website owner is participating in World IPv6 Day, you will only connect to them via IPv4, and you won't have a problem. If you, as an end user, are running IPv6 and the website owner is running IPv6, then in that circumstance, everything will work just fine as well. The only problem comes is if you are running a dual stack with a problem, or they are running a dual stack with a problem. If either of you have a problem with your IPv6 setup, you will have connectivity problems on that day. So let's take a quick step back and understand how IPv6 clients are served in a dual stack environment. The V4 and V6 networks are effectively independent and separate data paths. Your V4 network and V6 network are ships in the night. So if you have a website that's dual stacked on IPv4 and IPv6, IPv4 only clients will traffic through the IPv4 only path. IPv6 only clients, very few that there are, will traverse the IPv6 path. And a dual stack client, in general, if you support both IPv4 and IPv6, almost every application will prefer to make the IPv6 connection. So the IPv6 capable devices will try to use the IPv6 path if it's available. The issue is that on June 8th, the IPv6 path through the internet will see unprecedented stress as lots of formerly dormant clients suddenly become capable of talking IPv6. IPv4 sites will generally see no changes, is our expectation, except for any side effects of traffic patterns changing in the internet during that time. So now my polling question 2. Based on all this information, what is the primary impact you expect to experience on World IPv6 Day? Looking at your polling questions, it looks like most folks are in the phase of thinking about using it or playing with it in the lab, and I see that there are 3 people that invented IPv6 on this call. So thank you. I'm humbled that you all came. Hopefully, maybe I can learn something from you. So if we can bring up the second polling question, I'd appreciate to find out if you expect to have no impact because you're V4, or if your IPv6-enabled servers may suddenly have trouble, or if your IPv6 users may suddenly have trouble reaching Google and Facebook and therefore have a much more productive day at your office, or if you expect total pandemonium, or the best option, I think, is to go off to some Caribbean island with no phone or internet and let all this pass overhead. So, check back on those in a minute and a half. So what should you do? Well, this is a great opportunity to learn about IPv6 and about your capabilities at your enterprise network or at your website with IPv6. So first of all, alert your administrative and IT management staff that June 8th is an at-risk day, that the fact that a number of major websites are going to be changing the way they behave by offering IPv6 may cause some disruptions both on those websites and on the internet. So warn people that there's a possibility that day could be very interesting for your internet access. One thing you can do is look at the participant list at the ISOC website. The last I checked, there were about 150 participants. So if you know the people that are participating in World IPv6 Day and search that list, if you have trouble reaching those sites, it could be because they're running IPv6 or they're having problems running their 24-hour IPv6 experiment. If appropriate, alert your customers. And if you are running IPv6, make an attempt to measure the change in traffic on that day. See how important IPv6 is to your network. Even if you don't participate, if you don't have your main website speaking IPv6, one of the things you can do is on your website you can set up invisible iframe elements which attach to an IPv6 host, which in turn will count the number of IPv6 users. These two sites here talk about some of the research that's been done and some of the tools you can use to do that kind of measurement. See if your current measurement tools, your current website logging and reporting tools will support IPv6 tracking. And also, if you have NetFlow, if you work on NetFlow on your traffic edge, if your Cisco routers at your edge support NetFlow, take a look at doing IPv6 and IPv4 statistics. If you do dual stack your host, take a measure of what level of traffic is IPv4 versus IPv6. Since a lot of folks are going to be doing this on that day, if you have a small site, this is a great time to play around with that. If you also register yourself with the participant list on the ISOC site, there are a number of test organizations that will come and run a battery of tests against your site and collect additional statistics that day. So if you want your website to participate, or if you have even a lesser website, if you have your main website and a smaller website, you can even add your smaller website to the participant list and contribute to the measurements on that day. So it looks like most folks are running IPv4, and 11 people are on vacation. I would wish I could join you. I know what I'm going to be doing for those 24 hours, and it's going to be not sleeping very much. Finally, prepare post-event user feedback. If you have your users that were running, if you were running IPv6 in your network, and it looks like only a few of you are, it might be useful to prepare a post-event user feedback form with SurveyMonkey or something like that to see if people had any problems that day. So suppose I provide network service. If you are providing connectivity service to end users, what can you do? If you already provide IPv6, try to get native IPv6 from your ISP if possible. Comcast is one of the ISPs in the U.S. that provide native IPv6 service. Not a lot of them do, but otherwise you can use a tunnel broker like Hurricane Electric or Sixus or a couple of the tunnel brokers. You make sure you use a nearby tunnel server, and then also check to see if your tunnel server hardware, if you have a router that's providing the tunnel, make sure it's ready for the sudden traffic spike for carrying YouTube or Google traffic, and make sure that your path can handle the traffic spike as well. Make sure that you have, most of the reputable tunnel providers will provide a fine path. They're all beefing up for this event and they're ready for it. Make sure that your firewalls handle IPv6 ICMP correctly. This is tricky because one of the things that happens is that the neighbor discovery is all conducted at layer 3 instead of having a separate protocol like ARP and IPv6. So it's possible that misconfigured firewalls make it impossible for neighbors to discover each other. It's like breaking ARP. And finally, if you're in your own personal network, look at doing RA guard, router announcement guard, and first hop security to defend against rogue or accidentally configured routers drawing away traffic. There's an interesting white paper at Cisco saying you may be an IPv6 whether or not you know. That's not the title of the paper, but the fact is there's a lot of automatic tunneling protocols built into some consumer routers and also built into some modern operating systems. It may be interesting to do some investigation looking at this white paper to see, even if you think you're only providing IPv4, you may in fact be providing IPv6 services through tunnels and not even know it. So this is an interesting white paper to read to find out, well, am I an IPv6 provider and not knowing it? Do I have tunnels bypassing my firewall? It's a good read. And if you decide you want to start providing V6 through tunnel brokers, we have a document at the support forums. It's a quick start guide to finding and using a tunnel broker to provide IPv6 at your network. So again, this is if you're a provider of network service or want to provide IPv6 network service. On the flip side of the coin, if you're a website provider and trying to provide IPv6 service or participating in World IPv6 Day, do alert your users with a banner on the website that there might be problems on that day so that they're not caught flat-footed. Make sure that you have a Quad A or record, a DNS resource record that's published and correct. an A record and your RDNS record so that your site is reachable and does reverse DNS lookups. If you're a content delivery network like Akamai, or if you use a content delivery network like Akamai, make sure they're ready to handle IPv6. Two of the major content delivery networks, Akamai and Limelight networks, are providing IPv6 capability. So if you're using a content delivery network, check with your CDN and see what they're doing for World IPv6 Day. In some cases, if you're using Akamai or Limelight, they can actually transparently provide IPv6 service without you having to do a thing, where they provide the IPv6 connectivity and translate it to IPv4 so that IPv6 users connect with IPv6 with no problem. So it's worth contacting your content delivery network if you use one. So I'd mentioned something about putting in iframes and invisible web bugs. This is a great site to look at. This is a set of sample JavaScript applications that will test if you have IPv6 capable users visiting your website. So this is a good way to check in advance to see, well, are there IPv6 users coming to my site? Do I need to worry about it? Another thing you can do, what Cisco and a number of other folks have done, is you can offer a copy of your site at an alternate name. So if you go to www.v6.facebook.com, that's the Facebook website over IPv6, just like ipv6.cisco.com, ipv6.google.com, and ipv6.apple.com are all IPv6 versions of the main website. Again, when the website providers can convince themselves that there are enough non-broken IPv6 users, they can make their main property use IPv6 all the time. As it is, the whole point of World IPv6 Day is that all these providers are going to get together, lock arms, and jump into the pool all at once for 24 hours and see what kinds of things happen if they make their main website, instead of an alternate website, accessible through IPv6 only. And again, by all means, perform tests in advance of World IPv6 Day. Get your testing done. Don't get surprised. And this is the main part of the preparation for me. How can you test for readiness? And there are a pile of useful websites. What I like to do, one of my first sites I like to go to, it's easy to remember, is ip6.me. If you visit that, that'll tell you your IPv6 address if you have one. If not, it'll just tell you your IPv4 address. Test-ipv6.com is a pretty comprehensive site that does a battery of tests to see if your network works. And the similarly named ipv6-test.com, which is that one does a similar test, but that one also has a speed test and has the ability to test your website. So, and again, so IPv6-test will test your website, and ready.share6.net will also, if you've turned on IPv6 on your website, these two sites will run a battery of tests against your website and let you know how it works. One of my paranoid things when I first turned on IPv6, I thought it was very exciting because I was not using NAT. I was directly connected to the Internet. I had full peer-to-peer connectivity, and then it dawned on me, if I have full peer-to-peer connectivity, that means people can attach to me, and there's no firewall in between me and them. So Cisco's own Dan Wing threw together this little test, which runs Nmap on a server, on a public server. So if you visit this site running IPv6, it will do a port scan and see if you have any open ports to make sure that your host-level firewall is working well. Unfortunately, this MTU test has been taken down, is not available anymore, but one of the things that you do have to worry about is if your past MTU information is being returned correctly. A lot of sites are working around this problem by lowering their MTU to a smaller value of, I believe it's 12, I think it's a 1280 is the number that the MTU you're using on websites to avoid the possibility of MTU problems on the transport. But you should, we're waiting for an alternate MTU test to come online. When we have one, we'll certainly include that information at the support communities and in updated versions of this document. Okay. Thank you, Carlos. Carlos just warned me that 1280 is, in fact, the correct number for the MTUs for servers to use. So, IPv6 challenge. If you get IPv6 running on your network, clearly the thing you want to do is brag to your nerdy friends about it. So another Cisco employee Eric Vink has put together a Facebook application called the IPv6 Challenge. If you go to this application on your Facebook page, if you support IPv6, they will let you post a message with your IPv6 address proving that you can run IPv6 and challenging your friends to also get their systems ready for IPv6. So it's just a fun little Facebook app that lets you show off the fact that you can connect via IPv6. There's a complete, again, the ARIN Wiki is an excellent source of information. There's a comprehensive set of all kinds of test tools at this URL that you can use to test your site, and then a collection of test sites similar to this collection here, which will tell you how to do troubleshooting of both your server side and client side of IPv6. So there's a lot of help out there to be going forward. So where can you go for help? At Cisco, you can just go to cisco.com/go/IPv6. Talks about Cisco's positions in IPv6 and a lot of the products that we have available and things that we're doing. We have a comprehensive suite of professional services that you can use to help you through the transition at this link. And what we're most proud of is the self-service support community. Most of the panelists on this call spend a lot of time at the support community and can answer your questions. Any questions that we can't answer on this call, we'll be happy to answer offline at the support community forum, which is then subsequently searchable for all future users. So there's a set of all of the test tools that you can use. So I'm ahead of schedule with this talk, and I'd like to find out what you plan to do based on what you know here. So will you work on an IPv6 implementation plan for the first time? Will you accelerate your plan? Will you do nothing because your plan is already on track? Or will you do nothing because you don't care about IPv6 and don't expect it to affect you? Or do you plan to move to Africa or Latin America where they still have plenty of IPv4 addresses so you can spend a couple more years in denial about the rise of IPv6? So I'll leave that question to you, and I be very happy to answer questions for the next half hour around IPv6, preparing for IPv6, and other things that you might want to do.
Okay, we can kick into our first question from the audience. And remember, folks, you can submit your questions at any time. We do have plenty of time today to answer them, so get them in as soon as possible. Let's go to our first question here. I have Windows 7 clients that are dual stacked. I only route IPv4 internally and externally. Will my dual stacked clients have issues on World IPv6 Day?
And that's a great question. So if you're a dual stacked client, you can run IPv6 link locally on your wire until you get assigned a global IPv6 address through stateless auto address configuration or through DHCP v6. Your dual stack clients will not have a problem until they get a global IP address. The only way they will pick up a global IP address is if there is a router that will assign them a global IP address. So you actually have to have a router on your network configured to run IPv6, which will let them get a global address and in turn communicate with the global IPv6 internet. The quick check is if you run ipconfig on your Windows 7 device and take a look at the IPv6 address that's assigned. If it starts with the letter F, it's a link local address. If it starts with the number 2, it's a global address. So if you do have an IPv6 address that starts with the number 2 and is in fact a global IPv6 address, you do want to visit one of the test sites. Test-IPv6.com is my personal favorite, and it will do a quick analysis and tell you if you will have problems. But again, if you have a dual stack client but your routers aren't running IPv6, until you get a global IPv6 address, your device will not attempt to connect to the IPv6 internet. One of the other issues about that is you want to be careful because sometimes one of the things that may happen is you may be running there are certain home routers that will automatically build an IPv6 tunnel using an automatic configuration tunneling protocol called 6-4. It may be doing that quietly in the background without your knowledge, and then in turn advertising IPv6 router advertisements, which give your hosts IPv6 addresses. In that case, you will be running IPv6, and you are running IPv6 and don't know it. So again, the quick test is just go to test-ipv6.com. It will tell you if you're running IPv4 or IPv6. If you're running IPv6, it'll tell you your v6 address, and it will make a good estimation about whether or not you will have problems. The thing is, if you're running IPv6, that's not necessarily bad. So I see. Sure enough, one person is moving their network to Africa out of the call. Outstanding. I'm glad that there's somebody who's deeply in denial. So great. So this is a great poll. So it looks like it looks like we're split 50-50, saying it looks like we're a good 50-50 split between people who are starting their plans and people who have their plans on track. So it's a pretty good. Actually, it's a pretty good mix of people that are doing all different things. So all right. So I'll be happy to take another question.
Okay, let's go to another question. How would I buy an IPv6 address block for my company?
Your best bet to buy an IPv6 address block is to start by talking to your ISP. Because even if you bought you could get to answer the question directly, you can get an IPv6 address block from ARIN, ARIN. ARIN is the authority that hands out blocks of addresses. But what you probably want to do is, even if you get the block of addresses, once you have the block of addresses, you'll have to find a service provider that will carry that block of addresses for you. In most cases, if you're just starting out, you want to go to your service provider and say, I want to get a block of addresses from you. If you do want to get a service provider independent block, you would go to ARIN, but you still do have to find an IPv6 service provider that will carry and advertise that block on your behalf, even if you get a block independent of the provider.
Okay, excellent. Let's go to another question. Does IPv6 provide other benefits over IPv4 rather than just scalability?
One of the interesting and this of course has been the bugaboo all along with IPv6. People say, I don't really have a use for it because it just does the same thing as IPv4 except that it gives you more addresses. There's some interesting things that happen because of the way IPv6 works. It's one of the interesting things you get out of it is a management benefit. For example, one of the things that Google does, which I think is very interesting, is they run IPv6 almost exclusively in their internal network. And one of the things that buys you is because you can have multiple IPv6 addresses on an interface, the transition from one subnet to another is extremely easy, where you can take your old address and your new address and run them at the same time. So subnetting becomes a very easy process with IPv6, and changing subnets and subnet renumbering is very easy. So in terms of enterprise management, that's one thing you can do. One of the other advantages is you cut a stateful device out of your network. If you're communicating from IPv6 to IPv6, you cut the network address translator out of your discussion, which prevents network address translator timeouts. It prevents having additional state. It has one less device that can go wrong in the path. One of the things you're seeing now, I thought is very interesting, that World of Warcraft has adopted IPv6 now. The newest World of Warcraft client has IPv6, because one of the things you can do in a gaming scenario is, instead of going to some meet-me point that can do the translation to bounce you from one point to another, because one of the problems is if you and another person you're gaming with are both going through a NAT, it's tricky to make sure to send my packet directly through my NAT and through your NAT to you. And if you're running IPv6, direct peer-to-peer connectivity is a lot simpler. So in gaming situations, you can have reduced latency because you've got a more direct path, and you also cut out an additional, essentially a box whose only job is to be a relay for you to allow you to pass through NAT devices. So you do get enhanced peer-to-peer connectivity, some administrative advantages, and the additional address space. One of the other things is if anybody runs any BitTorrent applications, BitTorrent is very popular in IPv6 as well, because again, because a BitTorrent is a peer-to-peer application. Any kinds of peer-to-peer applications that can cut out a NAT device and cut out a meet-me center has much more efficient communication. So those are some of the additional advantages other than space and scalability of running IPv6. And I'm waiting for any of my panelists to jump in and add anything I might have forgotten. So cautiously watching my instant messaging from my panelists to yell at me and say I've said something wrong, but so far it's quiet. More questions.
Okay, more questions indeed. Here's another one. Are there DNS IPv6 test tools? It appears that DNS will be the biggest transition problem to IPv6.
The test IPv6 does a series of DNS tests, and I guess it depends on what DNS issues you're talking about. Some of the common IPv6 problems are the biggest DNS problems are if a host deals up bad information through DNS. So we've had situations. I'm not part of this testing. We have some researchers in Cisco who've done some interesting work. I could dig it up, but there are people that do things crazy like return link local addresses to DNS queries over the global internet, which is complete insanity. That's like returning an RFC 1918 address to the global internet. If I make a request for www.example.com and they tell me it's at 192.168.1.5, I just bang my head against the table because that's ridiculous. So a lot of the DNS testing, so the DNS itself is not going to be the problem. It's more people misconfiguring their DNS that's going to be the problem. And again, DNS can work over IPv4 or IPv6. It turns out that if you run your DNS protocol over IPv4, you can still learn IPv6 addresses over the IPv4 protocol. So that's not a problem. But doing DNS over IPv6 itself, there was a problem. There weren't very many public servers at one point, but there are more and more public servers appearing that speak IPv6 and do the DNS protocol over IPv6. So the testing tools, again, Test IPv6 will test to make sure that your DNS client is configured correctly. But in terms of your DNS server being configured correctly, that's a little trickier. I'm not sure of any particular test tools to make sure that you have made a sane DNS configuration on your server side. That's a good question. I would have to dig into that. A good question for the support forums where more people can look at it.
Okay, excellent. Let's go to another question. Do you expect stateless autoconfig or DHCP v6 to be more popular?
Oh, do you prefer vanilla or chocolate ice cream? That's religious warfare right there. I have a hard time looking into my crystal ball on that one. I love stateless auto address configuration because it doesn't require any additional configuration, except for the fact that stateless auto address configuration only gives you the address. It doesn't tell you anything about your DNS server. It doesn't tell you anything about any other things you need to know in your network. It just tells you your address. So I think stateless auto address configuration is going to win in places where there's low overhead and you need simplicity, like particularly in small networks. But I think in larger enterprise networks, it's been my experience in the enterprise that an enterprise IT department wants to maintain a lot more authoritative and administrative control over their desktop. So in places where greater administrative control is needed, I think you're going to find DHCP v6 is going to have a lot more traction because it gives you a lot more control over the client's parameters. So I guess as much as I enjoy the simplicity and elegance of stateless auto address configuration, I think that DHCP v6 is going to get a lot of traction because the enterprises want to have a lot more control over the nodes on their network. As a funny sidebar, a certain large client, a large company that was making a client did. So as my enterprise story, one of the issues is one of the large stack providers did not do IPv6 privacy addressing. And what they did was they only used the IPv6 address derived from the MAC address to the box. So lots of people complained, and they said, oh my gosh, you're exposing my MAC address, you're violating my privacy, you need to put in privacy extensions. And so they put in the privacy extensions, which gives you a new IPv6 address every time you boot. And then all the enterprises went crazy saying, you're changing the address on my end nodes all the time, you're ruining my accounting systems, you're ruining my trackability. So, and of course the stack vendor threw up their arms in despair, because the needs are not uniform throughout the entire user community on the internet. So I use the privacy and non-privacy addressing as a great illustration of why, I think you're going to see different people are going to be using SLAAC and DHCP v6 for different reasons. So more popular, they serve slightly different purposes. So I don't think it's a question of which one's going to be more popular. I think we're going to be stuck with both of them.
Okay, sounds good. Here's an interesting question. Is it true that NAT goes away with IPv6?
Another religious question. So, no, unfortunately, it doesn't. There is, if you look in the IETF, there is a NAT66 working group, which translates NAT to NAT. One of the issues that you have, one of the problems. So the good news is that although NAT doesn't go away, stateful NAT can go away. One of the biggest problems with NAT is that you're overloading port numbers onto IP addresses to try to pile more users onto a single IP address. And maintaining all that state and maintaining all those timeouts and maintaining all of that stateful-oriented mapping is one of the things that just makes you want to tear your hair out working with NAT. The good news is almost all the NAT66 proposals are all about translating one address to the other for administrative purposes. So, for example, if I have a provider-independent IPv6 address space inside my network, and I have 2 or 3 different carriers that provide provider-dependent space, I would use NAT66 so that I can maintain my address pool, but then project it out to provider-dependent address space seamlessly to my end users and seamlessly to my external users. And because the address space is so big, almost all the IPv6 NAT will be one-to-one, which means it'll be a completely stateless situation where once the mapping is in, the mapping can effectively stay there forever. So unfortunately, the good news is it will reduce the need for NAT if it's done right, but NAT, I don't think NAT will ever go away, tragically enough. As much as I would like to see it go away, I think that there are there are standards bodies that are working on IPv6 to IPv6 NAT translation, and there's a whole separate discussion about you call NAT64, which is allowing IPv6 addresses to be network translated into IPv4. So NAT64, stateful and stateless is a whole different discussion, but I assume that you're talking about when you go native IPv6, does NAT go away? It has the potential to go away, but there are still people that are using NAT for different reasons other than address overloading, and those people will still have a NAT standard to work with IPv6.
Okay, great question there. Just looking for another good question, and we have a couple coming in. What are the best practices to implement IPv6 on the access network? We don't see ADSL cable modem router vendors that have come up with a stable IPv6 code on the CPE devices, and it seems like they are running pretty slow on enabling IPv6 features.
And boy, I couldn't agree with you more. That is a great question. So that's a great funny story. So there are a number of native providers. Again, I tried out Comcast as an excellent example, but let me back off from Comcast for a minute. So supposing you can't provide native IPv6 to your edge, this is currently a dilemma with a lot of providers that have an enormous investment, for example, in IPv4 only DSLAMs, the digital subscriber line access multiplexers. So if you have a legacy DSL network that you've got millions and millions of dollars invested in as a carrier, and you need to switch it to IPv6, chances are a subscriber multiplexer is designed to drive costs down. So chances are it probably can't be expanded in the software or hardware to support IPv6. So what can you do? A provider called Free in France, Free.fr, pioneered a technique whereby they provided a head end and could do IPv6 tunneling inside IPv4 that required an absolute minimum amount of code in the CPE and had a fully stateless connection that could scale to a very large number. This standard eventually developed into what we know as 6RD, or 6 rapid deployment. So it seems like the best practice to implement IPv6 on a legacy access network that already has IPv4 is 6RD. The biggest stumbling block is that in order for 6RD to work, you, as the service provider, have to have control of the code of the CPEs. In Free.FR's case, they were fortunate in that they had custom-made CPEs and they controlled them all, and they were able to roll out to several million subscribers and update, which essentially turned on IPv6 overnight. For people that have a broad mix of CPEs, that will be a harder problem. But so the easy way to bring up IPv6 without touching your IPv4 infrastructure is to use 6RD. The inverse situation is that you could use there's a protocol called dualstack Lite, where if you start rolling out an IPv6 capable access network, you can provide IPv4 tunneled inside IPv6 to network address translation devices inside the core. So there are a couple different ways to do it. So the 6RD is one of the common ones, at least among the U.S. carriers. But 6RD is the way that the carriers are starting to do it, where you're doing tunneling, but you're doing tunneling where the carrier maintains the tunnel translation point. And let me see. It says has no ADSL cable modem routers come up with stable IPv6 code on CPE devices. Okay, so so for in terms of cable vendors coming up with stable IPv6 code, the best thing I can say is stay tuned. There's a lot of stuff happening in the CPE space right now for both native and tunneled IPv6 capabilities. So that's I hope that answers the question. If not, ask a clarifying question.
Okay, next question here. Are there any problems with the size of MTU while using IPv6?
Yes, there can be. One of the issues is in IPv4, the packet fragmentation can happen in the network. So any router in the network that gets a packet that's too big can fragment it and send it on its way. There are all kinds of interesting problems that come up with packet fragmentation, so the designers of IPv6 said no, there will be no fragmentation at the router. Only the hosts will do the fragmentation if it needs to be done. So that relies on the hosts reliably learning the MTU of the entire path from end to end. So there's a mechanism built in, Path MTU Discovery, PMTUD, whereby a router that receives a packet that's too big to carry will echo back an ICMP-v6 packet, ICMP-v6 type 2, called a packet too big message, a PTB message, and sends the PTB message back. As long as there's no brain-damaged firewall in the path that says, ooh, ICMP-v6, evil, evil, and stomps on that packet, if the ICMP-v6 packet can get through, your Path MTU works fine. Unfortunately, there are a number of misguided network designs that do things like block all ICMP. And if you have one of those networks, you can have MTU issues where if you send a too big packet and the packet too big message gets dropped on the way back to the sender, then the connection hangs forever unless you either lower your MTU to 1280 or lower your TCP MSS to 1240. It's an unfortunate situation that arises from over-aggressive firewall devices, and it's a great frustration for us in the IPv6 community. In fact, a number of there's some argument in World IPv6 Day about the major providers for World IPv6. A lot of them are providing an MTU of 1280, saying, I will never send a packet bigger than 1280, so nobody will have MTU issues. But there is one large service provider that's holding out, saying, you know what? I'm going to set my MTU to 1500 because I want to send bigger packets, and if people have trouble reaching me because of MTU issues, I want to get into debugging that. So there's currently one lone holdout. A lot of folks have thrown up their hands and say, PMTUD is unreliable, therefore I'm going to a small packet size. It's really an unfortunate position. So the question is, will there be MTU issues? When you have a misconfigured network that handles IPv6 wrong, yes, there will be MTU issues. And the consensus seems to be that the PMTUD mechanism cannot be trusted, but there are still a few holdouts saying, if we give up now, it'll never get better. So they're trying to there's a question of, can you reach enough people this early in the deployment of IPv6 to get those improper ICMP v6 filterings removed? And the answer is I hope so. But it's hope for the best, prepare for the worst. So we hope that those MTU blockage issues won't happen. But a lot of the larger providers are just saying we're just going to send 1280 packets. I believe the last I checked, Cisco was one of those organizations holding out for we're going to send 1500 byte packets and we're going to dig into these PMTUD issues. That was our stance the last time we checked. So check back with me after June 8th and we'll see if we still believe that.
Okay, I think we have time for one more question, and this is a good Cisco-centric question. IP4 and IPv6, how does this affect video communications, and are there any advantages or disadvantages between the two?
For video communications, it's probably I would think that they're about the same. I'm trying to think if I think there are more QoS bits available to play with in IPv6, but practically speaking, the way we currently use video, I think there'll be. I think video. I don't know of any particular advantages using IPv6 for video transport, other than the larger number of end hosts. And there's also, if you're doing video multicast, there's a larger number of multicast channels to use in IPv6. But I don't think there's any particular specific advantage to running multimedia over IPv6. So do you want to squeeze in one more question?
Yeah, I think so. We'll find one more here. If the translation of IP6 to IPv4 is done on a router, does this mean the end user will receive an IPv4 address?
In the case of that's the opposite way around, actually. If you're running NAT64 on the router, the idea is with NAT64 is that the clients of the router get an IPv6 address, and the router does the translation to reach IPv4 only hosts in the network. So the idea is that with NAT64, you could run a v6 only network inside your enterprise and have those v6 addresses still be able to reach out to IPv4 hosts. So if you're talking about the reverse situation where if I'm an IPv4 host and I want to reach IPv6 only devices, that's not the case that we want to do. If you want to reach an IPv6 device, there is a way to do that called NAT46, but that hasn't caught on, and we're not really implementing that. The idea is if you want to reach an IPv6 only device, we encourage you to run IPv6 in your network and then use NAT64 as the stepping stone to reach the devices that are insufficiently enlightened to be running IPv6 themselves.
Excellent. Thank you, Phil. That's going to conclude the Q&A portion of today's webinar. Just want to remind everyone that the first 10 listeners who fill out the evaluation will receive a $20 Amazon gift card. That evaluation will pop up as soon as you close your webinar browser. Also, just want to remind everyone that Phil Remaker will be available on the Cisco support community website at supportforums.cisco.com. And he'll be there for the next 2 weeks. If your question did not get answered or you're looking for a little bit more elaboration on one of your questions, please do make sure to post your question there, and Phil will answer them, and as well as you can participate in the community overall. So I just want to thank everyone and thank Phil Remaker for his time today. Great presentation, Phil.
Thank you.
And I'm going to hand it back to Stefan for the conclusion.
Thank you, Dan. And once again, this does conclude our session for today. Just a reminder, as Dan mentioned, that a short survey will be popping up as you close out your browser, and we do greatly appreciate your feedback. Thank you once again to Philip and all of our question managers for today. Thank you, and have a great day.